So in this video, I want to give a little progression of like how you traditionally deploy an application and how we've kind of reached a point where we are now, where we have like CDNs that are hosting all your static files. We have like edge computing, we have serverless computing and stuff. But let's just take it a step back to like the beginning of how do we deploy traditional applications, right? So traditionally you have a VM, and this could be like an EC2 instance or a DigitalOcean droplet, where you, as a developer or a system admin or whatever, you SSH into the box, or you run some type of like Puppet scripts or Ansible scripts to basically install a service. So this is like your service. I could say it's Express.js, since we're kind of doing Node on this channel, right? So you have a VM and you want to basically run your Express web API here. Maybe you have some static files that are hosted here, but this is traditionally how like you would kind of run stuff. And there's a lot of people who actually do this. They actually deploy services manually and kind of, keep them operational. What you can also do, is the VM's big enough, you can actually put a database here too, right? You could put a DB, but this is like very, very manual work. And a lot of people do not have the expertise to actually like SSH into a machine, set up Postgres manually, set up their service manually, have the DevOps chops to basically set up a PM2 service. So if you don't know what PM2 is, basically it's a script you can use or a tool you can use to basically continuously refresh and restart your service if it were to crash for whatever reason. Sometimes services run out of memory, sometimes they throw exceptions and they have to be restarted. But doing all this and then managing this database by hand, it takes expertise, right? And a lot of people don't have the time to learn all this. But this is kind of how like we were at for the longest time, and this works for a lot of small scale companies, right? This can handle a lot of traffic, especially if you're using like AWS, because you can vertically scale. You can start off with like a nano, and then you can go to like a micro. I think I had these backwards. So like you could start with a nano and see how that works. And then if that's not enough memory, you can go to a micro, and then you can go to small, you can go to a medium, you can go to a large. And at some point, like you'll have a VM that has like 16 gigs of memory and can handle a decent amount of traffic, right? But there's an issue with vertically scaling. At some point, you're going to need more memory, or you're going to need to be able to handle more requests. And this is just not going to cut it, right? But again, if you're running a small little startup company, this I think will work pretty well for the most part. But again, there's a lot of hidden costs with like managing this stuff yourself. You don't want to be SSHing into a machine. And then also I would recommend, like, unless you're working at a huge enterprise, you don't want to be messing with Puppet, Chef, and Ansible. Like, it's just a lot of overhead to understand like how to set up those orchestration tools on your cluster of VMs. So if that's out of the question for like a beginner, what are the next steps? Well, in terms of scaling, what you could do is you can move the database off into its own VM. Okay. Again, we're trying to like show you the progression of like, okay, let's split this out into two VMs now, so that my Express service is running on one VM and it communicates with a database that is running on another VM. Okay. And again, you can vertically scale both of these independently. Okay. So if your database has more needs, you scale it up. If your service has more needs, you scale that up. But again, like I said, at some point with all this vertical scaling, you will hit a threshold. And you don't want to be managing databases by hand. So what we typically do is we offload the database to a third-party service. So let's just go ahead and put one here. I'll just say like we're using Railway. I've used Railway a couple times on my service. So like basically you're saying I don't want to manage this myself, although this is probably like one of the cheaper options in terms of operational costs if you know how to like manage and monitor a database. But for most of us, we don't want to have to do that stuff, right? So what we do is we offload that responsibility to a service who has experts that know how to run a Postgres database. They know how to monitor it, and they know how to do security patches and updates on it, right? So you're going to pay a little bit more money, typically, because you're paying someone for their expertise to take care of managing this thing. And then like, Amazon has a RDS instance you can use. You can use like PlanetScale. You can use, what's the other one called? You could use like Supabase or whatever. But the idea is like, this allows you to scale better because again, typically this thing has the ability to vertically scale as well. And it's usually like a one-click button in the service to just scale it up to accept more traffic. But also remember, as you scale up, they end up charging more money, right? So keep that in mind, that these services, they work great in the beginning, but as you get more traffic and as you have more data needs, you need to keep track of how much they're going to end up charging you based on your usage. So that's one thing. You split the database out and you scale that separately. So what about the service, right? What if your service ends up needing to need more computational power? Okay, so what you can end up doing is you can copy and paste all of this stuff. Let's just group it and copy and paste it, and you could make different instances of it. Okay, so this is called horizontally scaling. Horizontal scaling, where you just create copies of the same service. And so that when a user needs to access this, let's just go ahead and put a user here. He needs to basically just randomly pick one of these things to do its request, right? So when he loads the browser up, he needs to hit something in front of all this. This is usually called a load balancer. You can use like Nginx if you want to kind of like set this up the manual way, which again, not a fan of, but I do just want to kind of talk about it so like you have some context of how this all works. What is a load balancer? A load balancer is basically sitting in between your services and your user so that the user says, I need to connect to your app.com, right? And what the load balancer says is, okay, well, I have two different services that are running. And what I'm going to do is I'm going to randomly pick one to basically forward that traffic to one or the other. There's different ways you can kind of implement this forwarding. You could do like round robin. I believe there's one called like sticky sessions, where based on your IP, it'll basically send you to the same service every single time. There's a lot of different strategies for distributing the load. But again, the purpose of the load balancer is to fan out every request so that one server is not overloaded with too many requests. You can keep the memory down and the CPU down on these machines. So as you get more and more scale, you need to basically keep on adding these things to this, right? You have to keep adding more and more and more, because in order to handle the amount of traffic you need, you have to basically keep scaling up. So that brings us to basically services that provide something called auto scaling groups. Okay, so if you've used like Kubernetes, or if you used anything in Amazon with like EC2 or managed instances, basically what you do is you give it a definition like this. I'm going to say, give it a definition. I'm going to go ahead and just put like auto scaling group. I know that's kind of like a convention that I think Amazon uses a lot, but basically, depending on where you're hosting your service, if you're using like, again, like Kubernetes, or I think Fargate is another one on Amazon you can use, you can set some numbers. And I want to say, you know, min is one server, min of one server, and max of 5 servers. And what this auto scaling group basically does, and typically I think this also includes your load balancer. You can kind of fact check me on this if you want. But now you have basically abstracted away the need to manage all that stuff yourself. And instead you're saying, hey, Amazon, you take care of this for me. You basically inspect the traffic of my load balancer. And if you notice that like I'm getting a lot of traffic, Amazon and other services will basically spin up another instance for you and do all that routing for you automatically. So let's talk about how do you actually like split up your API from your front end? Because right now we have like both of them bundled together. Like this is your API and your front end all being hosted from the same service. Like again, if this was like you manually hosting a Next application, it would be hosting your UI and your API, right? But at some point, depending on the size of the project and the scale and the team, you might actually want to deploy your API as a separate standalone service. Okay, because APIs typically end up having different needs. You might have more complexity, you might need more computation, and the UI might not have as many needs as well, right? So like the UI could be really simple. You might just need like 1 or 2 servers in your auto scaling group, but the API, let's say you do a lot of heavy computation, its auto scaling group might need to be a lot higher. You might need to say, I need a min of 3 servers and a max of 10 servers, or, you know, whatever. And so the idea is you would set this all up kind of separately and deploy this separately. You have probably, it could be in the same repo or a different repo, where when the user tries to load the UI, it's going to first fetch the UI from this setup. And then when the user browser needs to fetch some data, it would basically hit this other load balancer, which would go over here. Okay, so just looking at this, like you can just tell the complexity is starting to increase, right? This is not easy stuff to figure out, and it takes a lot of expertise to like get good at it. But what we've seen, at least with single page applications, is that, hey, you know, the UI doesn't really change that often. What we can actually do is we can deploy our UI to a CDN. So a CDN is basically a way to take a bunch of static files, and let's just pretend this is like the globe. This is going to be a bad diagram. Okay, this is the globe. Let's just move our database like back over here like this. Let's just pretend our API is connecting to this. Okay. So this is like a CDN, and this is like my example of like the globe, right? Let's just put the world. I'll just put regions here. The CDN basically is a network of different machines across the globe. And every machine has its own like caching system, which is going to basically take your UI and distribute it to all of these different nodes. Now, typically there is something called an origin server. I'll just put like a square here and put like origin. And that could be like an S3 bucket, which is holding your files. So like that's your compiled HTML, CSS, and JS. And the origin server, basically, when a user makes a request to the CDN, there's some magic going on where basically it's going to route them to the closest server based on geographical location, right? So if I'm in Florida, it's probably going to route me to an East Coast node. And that node is basically going to check, hey, do I have the files necessary to host this UI? If not, I'm going to go ahead and just make a request to this origin server. And I'm going to pull those files over, and then I'm going to cache them for some amount of time, right? So this is how we basically scale up all the static assets, like all the images, all the front-end JavaScript, the HTML. That stuff gets distributed to a CDN, and this stuff will live here for a certain amount of time based on whatever policies you have set up. So if the user decides to hit this thing again, this whole trip here is basically not needed because the files are already going to be cached. So that's the idea, at least recently, how the front end has been kind of scaled up and sped up. We have a CDN which hosts all the front end files, and I believe that's how like Vercel and other companies work. They have like the same concepts of your static HTML. Now, what you can actually do as well, if you're doing like server-side rendering, is you can actually put your API behind the CDN as well, right? So the user would make a request to the CDN. The CDN would figure out what region you need to hit. And based on different routing rules, you could have a route that goes to your API. And again, the same concept is you can have different types of cache policies, where if your API request returns some data, you can have it cached for 5 minutes on data that doesn't change that often. But again, this is how we get more and more into like, how do we handle more traffic? How do we handle more scale? And again, we're just trying to reduce the load on the servers so that we can handle more traffic. This has trade-offs. Caching always has trade-offs because sometimes when you cache data, it's going to be stale. And depending on the type of application, your users might need 100% live data. Other times they can work off of cache data. So you have to kind of keep that in mind and figure out those trade-offs. But that's how we scale up the front end typically. We use a CDN, and the back end, this is typically how we do it. Now, we can take this a step further because even the database, this is like a single point of failure now, right? So we have to be able to scale up the database, and what we typically end up doing, or services end up doing for you, is that again, kind of similar to the CDN, they will scale up your databases and distribute them to various regions, right? So for example, you might have a primary database here that's like in US East 1, but you might have replicas that are in West 1, or I don't know, the European Union or something. And what happens is that all of the writes typically need to go to like a primary database. And then once you write to that database, it distributes that data to other servers in different regions. So depending on where the user made the request from, your API can actually fetch data from the closest region to you and kind of speed that up as well. Now, this is not a simple concept either, right? So there's a lot of services that do this for you. I believe like PlanetScale will do this stuff for you out of the box. Like RDS will do this auto scaling replica stuff out of the box. You can use something like DynamoDB that kind of takes care of this type of large scale needs out of the box. But keep in mind that this stuff is not easy to do, which is why you usually just end up paying a service that takes care of this if you need this type of scaling. Let's progress this even more. Right now, we're just doing like hard-coded deployed servers. And again, these could be like Docker containers, or these could all be running on their own VMs. It doesn't really matter. Those are implementation details. But a movement that I think a lot of companies are doing now is instead of having like your Express server running on a dedicated machine, we're actually moving over to serverless computations. So let's talk about serverless. So that's also another thing that's like helping with scale, where instead of you having like multiple Express applications, you know, behind a load balancer, you actually have a function. And that function is basically scaled up based on your needs, right? So like Amazon has AWS Lambda. I'm sure Google has one. I'm sure Azure has one. But basically you have a function and that thing's going to scale up based on your data needs. The cool thing about AWS Lambda is that like these things can scale up super easily. Like if you have a burst of traffic where you have like thousands of requests that come in, you'll see your Lambda function just scale up like instantly and handle all that load. So instead of you having to like wait for this auto scaling stuff to provision a VM, set up your service, or if you're using like Kubernetes, provision a new container and let that load, which takes a little bit of overhead. This stuff is like almost pretty instantaneous, right? It takes like a second or 2 seconds based on the cold starts of these Lambdas coming up. And that is how you achieve another aspect of scale, right? It's just auto scaling all of these functions. And the cool thing about this is that every function is basically ran in isolation. So the issue I had before with like running an Express server, if you have like 100 requests going to the Express server and it crashes, you basically have 100 people who just like lost all of their request data. Versus on Lambda, every function is basically ran in isolation. So if one function throws an exception, the other 100 will not crash because they're all ran in isolation in their own kind of like execution context or whatever. So this is scaling on another level, which is also cool to understand. We have the CDN still for the front end stuff that could potentially be in front of your Lambda functions. That's caching responses as needed. And this is again like how Vercel kind of works. Like they have a bunch of API Lambda functions. So how do you scale this up even more? I think we should talk about edge functions. Now we have this ability to basically take execution, like take JavaScript code or take whatever type of code, and you can run it inside of an edge network. And again, the edge is going to basically take a user's request and run the code as close as possible to the user. So this is for scaling and performance reasons. Again, the way you scale is reducing the amount of traffic and load to your services so you can handle more requests per second. And if one way you can do that is actually have the computation live closer to the user and not have them need to go to the data center to like do this computation, because if you imagine this thing is going to be a little bit further away in terms of like distance from hopefully these things, right? There's different servers around the world and you're trying to connect the user to the closest one possible. So these two are probably going to be close in proximity and this one's going to be a little bit further away. So this has a lot of benefits because you can like reduce the amount of traffic that needs to go to your API, which again will reduce the amount of traffic that needs to go to your databases and reduce your load on your servers. So this solution isn't perfect either because at some point your edge function probably needs to talk to a database. And right now, you could either have the edge function talk directly to a database, which unfortunately some edge providers don't even allow you to run like binaries. So like running something like Prisma on your edge function might not even work. So you basically have to just make sure you do an API request from your edge function to your database if your database supports like those type of requests. And that can sometimes shave off some latency so that you don't have to go through the API. But I think it's worth mentioning that usually the API is actually super close to your servers, right? So the latency between the server and the database is going to be really low versus the latency between your edge function and the database will be a lot higher. So again, I think the main benefit of the edge function is if you can kind of filter out data and reduce the need to go to the database, you're going to speed up your system. I think where we're also seeing the industry go is we're having basically this need to have edge databases. So instead of having these like primary replicated databases, we're trying to find ways to get databases to be scaled inside the edge as well. So if every region has its own, front-end static files, it has its functions and it has its databases right here, this basically reduces a lot of the overhead of connecting to a data center. And I would say probably this is a lot more for like performance reasons and not necessarily scaling. But as you can tell, like all this stuff is complex, right? Like this is all being figured out and maintained and managed by expert DevOps engineers and system level engineers and database engineers. And it's not a problem that you really want to spend a lot of time trying to figure out yourself. So I think the benefit of all of this is that if you are at a small company and all of a sudden you get a ton of traffic and your like startup is blowing up because it just can't handle the traffic, if you use something like Vercel or these other services that kind of provide the scaling out of the box for you, you're going to be good, right? You don't have to worry too much about what happens if my server gets too many requests. Is it going to crash? And then my entire company's servers are going to be 404 errors. So using existing services will kind of take the responsibility of scaling everything manually out of your hands and just leaves it in their hands, and probably for good reasons, right? They've had years of experience doing it, and that is why you're paying them the decent amount of money for them to kind of take control of that type of stuff. So I think that's all I wanted to talk about. I don't know if this was a good talk. I feel like at some point I just started rambling and drawing circles and lines everywhere. But if you guys enjoyed at least listening to me ramble about this and how we've kind of went from a single simple VM deployment to something like super complex like we have here, give me a thumbs up. Also, I have a Discord channel you're welcome to join if you want to talk to me directly or just find a place to hang out with some other developers. It's in the description of the video below as a link. Other than that, yeah, leave me a comment if you think I completely messed up this explanation or there's something I left out. I'm always eager for feedback. All right, have a good day. Happy coding.